Alright guys, so hello. I'm just going to go ahead and move right on into this material real quickly. This is going to be a brief review for those that need like an in-depth review of how to rationalize a denominator, I would certainly go check out a different video, but this is just a quick review because um, yeah, I just needed to get a video out for this. That way you guys had it just in case you're having trouble with this, okay? This is useful for anybody in Algebra 2 or Algebra 1 or pre-algebra. Basically, if you don't know how to do this, you probably should if you know me for whatever reason. So rationalizing denominators. This is a process. By the way, this is just a fancy way of saying getting rid of denominators in the bottom of a fraction. So this is something like 3 over root 6. Okay? Now, technically, and for all intents and purposes, like this is not a terrible answer. It is realistic and whatnot. But it's what we would call like non-simplified. It's kind of like this is a fine answer, like 3 over 6. That's not really wrong. It is still 1 over 2. Like this is a prettier answer. It is completely simplified. This just simply is not. It can go further. So just like this can go a little bit further, you can take this one a couple steps further. Now, a lot of people might argue like why can't I just leave it like this, because the square root of 6 is a number, it is a decimal, okay, so it's going to be some kind of long decimal chain, and you could easily type into your calculator 3 divided by the square root of 6 and you'll get some kind of answer. um, to be honest with you, I can't really argue too much with you there, but what happens is that when you're dividing this mathematically, because the square root of 6 is an irrational number, you're going to end up with a um, really ugly answer or really irrational answer. Like it's not going to look good. It's not going to be functionally useful, and you are definitely going to have to round. So to avoid having to round, you do something called rationalizing denominators. Don't, oh my gosh, that was the worst. Okay, redemption. I don't know what that is. But when you're rationalizing denominators, you've got this square root in the bottom. And it's not that you can't have a square root in the bottom, it's that it isn't simplified. This is a lot like this. Okay, so don't stress it when teachers ask you to rationalize the denominator. We're not just doing it for kicks. It does have a purpose. It's because you can get much prettier numbers that are not rounded. So you try your best not to round things in mathematics. This is why I stress so much that I don't like decimals, I don't like calculators. Because as soon as you start dealing with irrational numbers like the square root of 6, so if we were to do the square root of 6, you'll get like 2 point, what is that, 2.7 something? Hold on. Let me just go ahead and grab a calculator for this. So square root of 6 is, oh, I'm so sorry, 2.44. All right, so this is 2.449 or 2.45, something like that. But this would be like 3 divided by 2 point, technically 4, 4, 9, 4, 8, 9, 7, dot, dot, dot. So it keeps going and going and going. So it is going to be an irrational number, and when you divide that by that is 3 divided by 2.499, something, 449. 489, etc. And you're just going to keep going. And you're going to like 1.22474 or whatever. And it's going to keep going. This sucks. Like, you don't want these non-terminating decimals. You don't want some kind of weird, random, long string of numbers that you're going to have to round at some point or another. That's definitely not your goal here. So, what we're going to do is we're actually going to rationalize. Rationalizing denominators works like this. And it's really simple. There's really only like two steps, okay? First step is multiply by whatever your radical is. Multiply by root 6 over root 6. And make sure to put it over itself, okay? Whatever this is, I don't care if this is like the square root of 130. That said, I'd highly recommend that you simplify your radical first. I'm not writing it as a step because you should, but you don't have to. If that's confusing, if you're not comfortable with simplifying radicals, which was a video from way long ago, I would definitely do it like this instead and just use whatever this number is. As big as it is, you can easily do it that way. You'll just have to simplify later. So it just depends on whether or not you want to simplify later or earlier. I typically simplify earlier in a problem, but, or actually, no, that's not true. I do simplify later in a problem. So, I mean, I would do it later. I'll actually show you an example of that right after this. This will still be a quick video, but we'll do it anyway. So we'll just go and multiply. Use multiply right across. 3 times root 6. You just put them right next to each other. And the square root of 6 times the square root of 6 becomes the square root of 6 times 6. Alright, and I am going to write out every single step of this just so you understand what's happening. But the square root of 6 times 6 is 36. What is the square root of 36? Hopefully everyone here knows that the square root of 36 is just 6. So you get 3 root 6 over 6. And then 3 and 6 can cancel. You'll end up with a 2 at the bottom. So you get root 6 over 2. So that would be your final answer here. And this would be considered done. All right. So what I did here was, what you'll notice is square root of 6 times the square root of 6. Anytime you take a square root and multiply by itself, you're just going to end up with what's underneath the square root. And this is why. So, 6 times 6 is 36. Square root of 36 is just 6. So you'll end up with the same thing. That's why I said that you just multiply by whatever your square root is, because you don't even really have to do the math. Like square root of 150 times square root of 150 is 150. Square root of 84 times the square root of 84 is 84. Square root of a million times the square root of a million is a million. So it's a pretty easy process if you do it like this. Okay? So that's just how to rationalize the denominator. It's really only 2 steps. Multiply it by itself over itself, and then do the math. That's it. Your last step would be simplify. So multiply by itself over itself, simplify. Cool. Let's go ahead and do this one with like a slightly larger radical, just to show you what it looks like. That would look something like this. 2 over square root of, let's say 20, because that can be simplified, and we could do that now. But let's say that you don't notice that it can be simplified. You just multiply it like this. That's okay too, because what's going to happen is you're going to do 2 root 20 all over 20. And then your 2 and your 20 will cancel. 1 root 20, I wouldn't normally write the 1, but I'm going to write it just for demonstrations purposes, all over 10. Okay. Now, the square root of 20 can be simplified. So let's go ahead and simplify it. Remember, breaking down that radical, you find your pairs, 4 and 5. And you'll notice 4 is a perfect square, so we can go ahead and pull that out. So we'll pull out a 2 there. So your final answer would be 2 root 5 for this. So square root of 20 breaks down into 2 root 5 all over 10. And you can break these. 2 goes into 10 5 times, so this is root 5 over 5. Okay? I know that was quick, but if you're not comfortable simplifying radicals, you should be watching a different video for this, but this is just how to rationalize your denominator. Okay? Hopefully there aren't any questions. There are really only 2 steps. 2 steps, okay? Multiply by the square root over itself, then simplify everything. Over and over and over till you're done. I can't simplify that any further, so I'm done. That's it. That's rationalizing denominators. Okay, I know I went through that quick. If you have questions, feel free to ask me. If I do need to make a more detailed video, I don't really mind, but I wanted to keep this one super short. Anyway, guys, have a good night. I will talk to you guys later. Bye.